everyone, me again. Welcome to topic 8.3, applying a regression analysis to your business report data. Here I'll work through a regression example using real data and I'll point out how to interpret the output. This should really help with your business report assessment. The learning objectives are shown on the slide. Please note that this is a working example of regression analysis. So Doina has already covered in much detail regression, the theory and all these sorts of things, and I'm here to apply this to an example using real data. So my focus is on interpretation. Okay, so here's my example. A friend, let's call her Jane, would like to sell her old and much loved car, a 2009 Toyota Corolla. This friend does not know what price to list her car for sale, but she knows she wants to list it online. So she looks at websites and in particular carsales.com.au, and she notices that there are many cars with different features, but really this still doesn't help her know what price is a reasonable price for her car. In order to understand a fair price to list her car, I decide to help Jane by using regression analysis. Look, Jane's eyes light up at the thought of an exciting statistical tool that will help her with this problem. The research questions in this case are, firstly, which factors influence the online list price of a 2009 Toyota Corolla? And secondly, what online list price is reasonable for Jane's 2009 Toyota Corolla? The objectives are outlined on the slide. You will notice how these objectives really link to the research questions. So here's some information about the data in the sample. Secondary data was used instead of primary data, and the data was sourced from carsales.com.au. This is one of the most popular online websites for selling second-hand cars. All Toyota Corollas listed on the website from the years 2008 to 2010 and located within 25 kilometres from Perth were included in the sample. So this is basically how the population was defined, and so the results will only really apply to these types of vehicles. This sample, I should say, could be considered a cluster sample. Okay, so here's the data. The data's on this slide and the next. And as you can see, I have data for the list price, which is the first column, and this is my dependent variable. This is what we're trying to predict using our independent variables. So the independent variables I've chosen are firstly usage, and this has been measured by kilometres, and it's the kilometres that were listed in the ad. Another variable I've included is seller type, whether the seller was private or a car dealer. And so this is a 0 and a 1, and this is what we call a dummy variable. I'll explain this later on. We also have colour. So colour is whether the car was blue or not blue, because in Jane's case, her car was blue. So it's trying to figure out how much more or less she can expect for having a blue car, selling a blue car. Again, I'll explain dummy variables a bit later. Okay, moving on, there's a variable there, the length of comments, and this means how many words were included in the description of the car and its features. There's also a column headed with photos, and what this is the number of photos that was included with the ad. I think the maximum here was 20 and the minimum 0. You don't actually have to upload photos. The transmission type is also included, and this is to do with whether it's an automatic or manual. Because Jane's car is an automatic, this was allocated 1 and manual is a 0. Lastly, I've included a column with year, but this is more for my reference to just show that this is all the cars that listed from 2008 to 2010 that are Toyota Corollas, hatchback as well. So here's the rest of the data. Okay, now let's talk about the variables. The dependent variable here is list price. List price is defined as the price presented on the website, and it's measured in Australian dollars. Look, I'm using list price as a bit of a quasi measure for the actual final price, but I acknowledge that it isn't the final price the car sells for. So I will always call this list price because it's the price that the car's been listed for. And Jane's looking at what price to list her car, so that makes sense. The independent variables included are called usage, seller type, colour, number of comments, number of photos, and transmission type. These variables will be used to try to predict or help predict the dependent variable of list price. So I'm going to talk about these in more detail on the next slide. Okay, so the first independent variable is usage. When you're labeling variables, it's often a good idea to look at the overarching label. So what I have here is the label being usage, and I provide a definition and measure, and then the hypothesis. So in terms of a definition, usage is defined as the amount of wear and tear that has occurred with the vehicle. And in this case, I've measured that as the number of kilometres that's been stated on the website, and presumably the same number of kilometres that's on the odometer of the car. But think about that, because I've labelled it usage, I could have equally measured it in terms of the number of dents of the car, the wear of the tyres, the amount of fading of the paint, and so on. But here I'm showing you my label, which is quite broad, which is good, my definition, my measure, and then my hypothesis follows on from that, and I justify my hypothesis too. Firstly, I say it's expected that the greater the usage, the lower the list price. And I think this is attributed to the fact that there will be greater need for repairs, for servicing, there'll be less life remaining on the vehicle, and so on. So I think this makes sense, right? The second independent variable I've included is seller type. And seller type is a categorical variable. I've defined this as the type of seller, whether it's a private seller or a car dealer, and it's a dummy variable, which means you allocate a 0 or a 1 to the different categories, and that you only have 2 categories per column of data. So here, 1 is private seller, 0 is a car dealer. I always think you should attribute the 1 to the category that you're interested in, but because Jane is a private seller, I've allocated 1 to private. The hypothesis is as follows. It is expected that if the seller is a dealer, the list price will be higher. And I've put the reasons for that on the slide. The third independent variable is colour. Colour relates to the colour of the advertised car, and this is also a dummy variable. Because Jane's car is blue, I've allocated 1 to if the car is blue and 0 if it's not blue. So all other colours except blue. In terms of the hypothesis, this is what I'm saying. If the car is blue, then I expect it will yield a higher price because blue is aesthetically pleasing and often people's favourite colour. Look, I have to go one way or the other, and that's how I'm justifying it. Let's see what falls out in the data. Okay, so my fourth independent variable is comments, and this is defined as the quantity or number of comments in the comments section, and it's measured by counting the number of words included with the online listing. What I'm expecting is the greater the number of comments, the higher the list price, as number of comments may reflect the additional features associated with the car, and so on. In terms of photos, this refers to the number of photos included with the car advertisement, and it's measured by simply counting the number of photos that were included. It is predicted that the higher the number of photos included with the ad, the higher the list price, as this probably reflects the quality of the car and the number of additional features associated with the car. Lastly, I've included transmission type, and this relates to whether the car has an automatic or manual transmission. It's measured as 1 is automatic, 0 is manual. It is predicted that if a car has an automatic transmission, then it will have a higher list price, as these cars are often more popular, especially for smaller cars, and the cost when they are new is generally higher, generally attracts a higher price, and so I would expect this in a second-hand car as well. Now presenting the data after describing the hypotheses and so on, the measures and so on. Presenting the actual data, I've got the numerical data here, and I've presented that as a histogram for those 4 variables. Remember, in your report, the focus is on the dependent variable, in this case list price. But here I've presented the histograms, and you would want to talk about each of these. You don't just present a graph, you need to also describe the graphs. For my categorical variables, I've included pie charts, and in your report you would need to describe these as well. And now I just want to show you how you calculate or compute your descriptive statistics using Excel. So what we do is, using Excel, and in particular we need to use the data analysis toolpack. If you haven't activated this in Excel, have a read of your textbook. If your version of Excel is a legitimate version, then this data analysis toolpack will be sitting behind the scenes, and you simply need to take around 3 to 4 minutes to click on a few things and it will appear in your menu. So once you've done this, you need to click on the Data tab and you'll see an option Data Analysis. For some of you, depending on what version of Excel you have, it might sit in add-ins, and if you have a Mac, look, it will sit somewhere, but you can still use it with a Mac. Have a look online and they have some patches and things like that if you've got a Mac. So once you click on this data analysis tab, you'll have a window open up like you'll see on my slide now. And you've got all the options, you've got ANOVA, correlation, and so on. So for this descriptive stats, you click on descriptive stats. Now in terms of the input range, you input all of your data at once. So I would select all of my variables, including list price, and I like to take the labels as well. And what you do is you select the box that says labels in the first row, and then your output will contain those labels. Also make sure the summary statistics box is ticked, and then this is the output that you'll get. So here are your descriptive statistics. As you can see, there is the mean, median, mode, standard deviation, range, minimum, maximum, count, standard error, kurtosis, skewness, and so on for each of the variables. Excel doesn't know if your variable is categorical or numerical, so you need to think about what's relevant to report if your data is categorical versus numerical. So for example, with categorical data, it makes no sense to talk about the mean. Next, we need to produce scatter plots. So you do this through the charting option. It's actually quite easy now with Excel, so have a play around with that. Just keep in mind a few things. We always put our dependent variable on the y-axis or the vertical axis, and each of our independent variables go on the x-axis or the horizontal axis. Here you can see I'm presenting the relationship between the number of comments and list price, and to me it looks like there's no relationship there really. So it's always good to look at our scatter plots first before looking at our correlation coefficients. Okay, now here you can see the relationship between the number of photos and list price. Again, weak to no relationships there, in my opinion. And thirdly, here you've got the relationship between usage, so kilometres, and list price. And look, I think there's probably a moderate negative relationship there. That's what it's looking like to me. This makes sense. This is what I hypothesized. What that's saying is, as the number of kilometres increase, the list price decreases. Exactly what I was expecting. Okay, so after checking our scatter plots, we take a look at our correlation matrix with our correlation coefficients. Look, it's important not to skip the step of observing our scatter plots, as these plots will reveal a curvilinear relationship that our correlation coefficients just won't show. So correlations are always about linear relationships, where our scatter plots will show us different relationships that might be there. To run the correlations through Excel, what you need to do is select the correlation option from that data analysis box. So you can see this on the screen. And now what you need to do is select all your data and then make sure you tick the box that says labels in the first row if you are actually taking your labels, which I would absolutely recommend. Again, it's a good idea to have your dependent variable in the first column, because then in your correlation matrix it will also appear in your first column, and this makes it a lot easier to read. Another tip is to have really short labels here. Doesn't mean you're messing around with your variables, but having short labels means in your output it's a lot easier to read. So here's the correlation matrix for my data together with my interpretations. So note that the correlation matrix includes correlation coefficients for all relationships, because I have the dependent variable in the first column, it also appears in the first column here, and so then it's really easy to see the relationship between each independent variable with the dependent variable. So that's kind of what we're most interested in as we move forward to regression. When we interpret these correlations, remember we're looking at the strength of the relationship, and that's shown with the number, and also the direction, and that's the sign, be it positive or negative. So you can see my interpretations there. So there's a moderate negative relationship between usage and list price, moderate positive relationship between colour and list price, and so on. So I've just put how I would interpret these correlations. And my rule of thumb, and this isn't everybody's rule of thumb, but this is mine, is what I say is that if we look at the correlations, so just the number, don't worry about the sign, so the absolute correlation coefficients. And I think between 0.7 and 1 is a strong relationship, between 0.4 and 0.69 is a moderate, and between 0.4 and, below 0.4 to 0 is a weak relationship. So please note, this isn't a hard and fast rule. Many researchers in my area use this, but in other areas would say other things. but it just is good to sort of have a way of that you interpret your correlations. So that's my way.